and then just go back to this idea of plugging things in. Okay, in this video we're going to look at an example related to the limit laws. So, just a couple problems here, and suppose that we're given that the limit as x approaches 2 of our function f of x that equals 4, and the limit as x approaches 2 of g of x that equals negative 5. We want to compute each of these following limits. So, part A, we've got the limit as x approaches 2, 3 times f of x minus 2 times g of x over f of x. Part B, again, will be the limit as x approaches 2 of f of x times g of x plus g of x. So, let's do part A here first. For the limit laws, maybe we'll go through this one in bits and pieces. If you have a limit of a fraction, it basically says you can take the limit of the numerator over the limit as x approaches 2 of the denominator. Okay, well, there's also some more rules that say, okay, if you have addition and subtraction, it says you can look at the limit individually. So we'll have the limit as x approaches 2 of 3 times f of x minus the limit as x approaches 2 of 2 times g of x. Again, in the denominator, I'm going to write it a little closer. We've got the limit as x approaches 2 of our function, f of x. Another one of the limit laws simply says if you have constants being multiplied by your function, you can factor those out. So we have 3 times the limit as x approaches 2 of the function f of x, minus, I'm going to pull the 2 out front, 2 times the limit as x approaches 2 of g of x. Well, again, all of that is over the limit as x approaches 2 of f of x. And now we're in a position to start plugging in the given values. So the moral of the story is you can basically just plug things in. A lot of people, very few people write all this stuff out when doing limits. So let's see, we said the limit as x approaches 2 of f of x, that was given to us as 4. So I'm just going to plug that in. So we'll have 3 times 4 minus 2 times, well, when we do the limit as x approaches 2 of g of x, we said the limit as x approaches 2 of g of x is just negative 5, so let me plug that in there as well. And again, we just said the limit as x approaches 2 of f of x, that's giving us the value 4. And now we're in business, we can just do our arithmetic. So 3 times 4 is 12, negative 2 and negative 5 is positive 10, all over 4. Let's see, that's 22 over 4, which we could reduce. We could make that 11 over 2, or I guess that's what, 5.5. So that would be our limit, the answer to the limit question in part A. All right, in this video I'm going to look at a little bit more of the limit laws, and this is kind of an important little result. It says if you have a function that's continuous at some number a, it says, well, then the limit as x approaches a of the function equals f of a. So really what this says is, it says if you have a continuous function to evaluate a limit, just plug in the number. That's all you got to do. So I think we can go through these, in fact, pretty quickly. So if you look at the limit as x approaches 1 of 3x plus 5 over x plus 4, if you think about the function 3x plus 5 over x plus 4, this is a rational function. The only place where they're not continuous is where they're undefined. Well, this is going to be undefined at negative 4, but that's not where we're doing the limit. So it says, well, to evaluate this limit, all we have to do is just simply plug in x equals 1 everywhere that we have an x. So we would get 3 times 1 plus 5 over 1 plus 4. Well, that's going to be 3 plus 5 or 8 over 5, and that would be the answer to our limit. So to me, basically, it seems like most calculus problems when you see limits, remember it's bad to divide by 0. So as long as you're not dividing by 0, plug it in, and whatever you get, that's typically going to be your answer. Okay, so again, that's not true in general, but most of the functions that you see in a calculus course are going to be continuous functions. Okay, so same thing with the next problem. If you think about x squared plus x minus 6, that's just a parabola that's opening upwards. Well, parabolas are continuous everywhere. Well, in particular, it would be continuous at 0. So I'm just going to plug 0 in, so I would get, well, 0 squared plus 0 minus 6, or it says you would just be left with negative 6 as your solution. Okay, so here we've got x plus the square root of x plus 11. And if you think about the function y equals x, that's a nice continuous function. Square root of x plus 11, that's just actually a square root that's been moved over a little bit to the left. Well, there's a rule that says if you add two continuous functions, it stays continuous. And so again, all we're going to do is just plug in the number 14. So we'll get 14 plus the square root of 14 plus 11. Well, that's going to be 14 plus the square root of 25. Well, the square root of 25 just equals 5. So we get 14 plus 5, or the value to our third limit here would simply just be the value 19. In this video, I'm going to talk a little bit about one-sided limits and a few different problems here. Probably what I'll try to do is make some sense out of it by graphing, but then also we'll just kind of talk about how you would do it algebraically. To try to how you would evaluate one of these limits, say, without resorting to graphing, but just to get some intuition. So let's look at part A here first. We've got a little piecewise function. So we've got the function f of x is going to be x plus 3 if x is less than or equal to 1, and then we've got x squared minus 2x if x is greater than 1. And we want to figure out the limit as x approaches 1 from the left. Okay, so notice the little minus sign is kind of to the right and above. So what that means is we're coming from the left of our function. So, okay, well, we could graph this. Do a little rough sketch here. So if you think about y equals x plus 3, well, that's just going to be a line with a y-intercept of 3 and a slope of 1. So, but notice it only looks like that for x less than or equal to 1. So if we plug in x equals 1, we would get the y value of 4. Okay, so there's going to be a point at 1, 4. Again, normally the lines just go on forever and ever and ever, but in this case, well, it's only valid for x coordinates less than or equal to 1. So we're only going to get the left half of this nice little line. Likewise, you can think about graphing y equals x squared minus 2x. Well, to graph this one, you can always maybe start plotting points. Notice if you plug 1 in, you would get 1 squared minus 2 times 1, which would be 1 minus 2, or negative 1. So there's negative 1. But since it's only valid for x strictly greater than 1, we're going to put a little open circle there. We could also think about finding the vertex if you want to just make sure that your graph is really nice. So remember to find the vertex of a parabola. We can use the formula negative b over 2a, but just to remind you of a few little algebra things here. So negative b over 2a, in this case, it says we would take the negative, and again, b is whatever the coefficient on the x term is. So we would get negative 2 all over 2 times a. So in this case, a would be the coefficient in front of x squared